We're going to be talking about something called domain and range, and that's a way to describe something about the x variables and y variable of a function. Before we do that, though, we're going to have to come up with a notation to describe this stuff. So we're going to take a look at a number line. Let's make a number line. And let's say it goes from 0, so -1, -2, -3, -4, 1, 2, 3, 4, 5. And I have some points on a number line. So we'll say this point, this point, this point, and this point. And we want to describe those numbers. And what we're going to do is we're just going to list them. So we're going to do something called a curly bracket. That's a set. So we're going to do a set of numbers. And it's going to be -4, -1, 0, 1, and 2. And that's the set of values that we've marked out over there. And if I put more points, I can just put more numbers, and that's pretty straightforward. But let's say I wanted to describe, so let's say this is my number line, and this is our 0, 1, 2, -1, -2. Let's say I want to describe the numbers, say from 1 and all the way up to infinity. And the problem is if I try to list those numbers, of course, so we'd have 1, and then we'd have 1.1 and 1.2, and don't forget 1.01 and 1.17 and 1.132 and 1.41632 and 1.41633 and it's going so forth. And in fact, there's an infinite number of numbers here, right? There's an infinite number of numbers that are above 1. So listing the numbers is not going to work. This is kind of a crappy plan of doing this. So we need another way of describing it. So we're going to segue briefly into number sets. So what number sets are, you have, for example, all the integers. And the integers are, so we have the integers. And the integers are like -4, -3, 2, 5, 7. It's kind of the whole numbers. This is what we often call whole numbers, but whole numbers are usually just the positive end of it. Integers are the negative and positive numbers. Then what we have is we have rational numbers. We have rational numbers, and we have irrational numbers. So rational numbers are all numbers that can be written as a fraction, and that includes the integers, actually. So 4 out of 7 is rational, and 2 over 1, which is just 2, is rational, and 11 over 77 is rational. Irrational numbers, also rational numbers are ones that have repeating digits. Irrational numbers are ones that cannot be written as a fraction. So for example, √2, pi, there's no way to write those as a fraction. So rational numbers, irrational numbers, and then all together, these two together, the rational and irrationals together, we call the real numbers. And we're not going to be talking about it at all, but if a number is not real, then it's imaginary. And imaginary numbers are actually a thing in math. And they're a thing in physics too. And they're kind of interesting. So imaginary might be, for example, the square root of -2. And the square root of -2 is, or -4 even. Square root of -4. And that's, the square root of -4 is not, it's not a real number. You can't, if you put it in your calculator, you get an error. It's an imaginary number. Now, why do we care about these numbers? We care about these numbers because we actually, in math, have symbols for them. And the symbol for, I'm not 100% sure, but I think, and the way we show it is we do these kind of double lines to show that it's a set of numbers. So integers is Z, and rational is Q, with that extra line in there. And the symbol for real numbers is actually this R with a double thing in front. And so a real number is a number that's irrational or rational or integers or whole numbers. It's any number that's not imaginary or any number that you could possibly think of. Ooh, that went off the screen. So just to review, the symbols have these kind of double lines, the Z, the that, and the R. I'll show you how I draw it again. That's how we do the R that shows real numbers. And why do we care about that? Because we're going to do another thing. This over here is, looks like a backwards E. It's an epsilon. It's a Greek letter epsilon. And it means a subset of. So for example, if I said that x epsilon fruit, what I'm saying is that x is a part of the thing that we call fruit. So x might be, for example, that was a terrible curly bracket. Better. X might be apple, banana, strawberry, etc. And that would be the set of things that are fruits. So where am I going? Putting that all together, if I say x epsilon r, I'm saying that the variable x is part of real numbers, which essentially is saying that x could be any number possible. So going back to our example, let's say we had a number line, and this thing over, these arrows mean infinity, so -1, 1, -2, -3, 2, 3. So if I wanted to describe, let's say it went all possible numbers. It went from -infinity all the way to positive infinity. What I'm going to say is, I'm going to say, okay, the way we're going to describe this is, it's the set of numbers where x is one of those real numbers. And that's the way we describe that one.